Hey guys, welcome to your practice problem. So I'm going to work through number 1A with you on page 356, and then your Junopod is going to be you doing 1B through 1E, okay? So if you want to know exactly how to do this, exactly what I'm looking for in those in those boxes, this is what it is, okay? So you're going to need to do some calculations outside the box and then type in your answers in the box, okay? So this asks you to interpret the following balanced chemical equations in terms of particles, moles, and mass, okay? So I'm going to do 1A, which is this one, N2 nitrogen plus 3H2 hydrogen gives us the product of 2N3 or NH3. All of these are gases, okay? So let's get started. First of all, I'm going to put all of the things that I would expect you to write in the answer box down here. And any of my miscellaneous calculations that wouldn't need to go in the answer box up here. Okay, so step one is interpret this chemical equation in terms of atoms, molecules, formula units. Okay, so how we're going to start is we look at how many atoms of, or how many molecules of N2 we have, and we have one. Okay, so my first interpretation is going to be 1 molecule of N2 plus, and we can use the mathematical plus sign, plus 3 molecules of H2 gives us how many molecules? 2 molecules of NH3. So the first interpretation that I'm expecting looks like that. It has to do with molecules, formula units, or atoms. Okay? Now, the next one has to do with terms of moles. And moles are pretty simple because it's the same ratio as your molecules. Okay? So we have 1 mole of N2 plus 3 moles of H2, which gives us 2 moles of NH3. All right? And that's my interpretation in terms of mole. Now, the last one is the interpretation in terms of mass, and this is the one that does require a little bit of calculation. Okay? So we need our molar mass of N2. Well, we look in the back of our book at the periodic table, and we discover that the molar mass of 1 the molar mass of 1 mole of nitrogen is going to be 14 point, I'm going to round to the hundredths place, 14.01 grams, okay? So that means that N2, so 2 nitrogens times 14.01 grams over 1 mole gives us 28.02 grams for N2, okay? We'll do the same thing for hydrogen. Here we have 6 total hydrogen atoms, okay? So 6 hydrogens, and the molar mass of 1 hydrogen is 1.01. Again, I'm rounding over 1 mole. So 6 times 1.01 equals 6.06 grams, which gives us for 3H2. That's how many grams those two things are. Sorry, those are your answers. These are the calculations that I just did, okay? Calculating the molar mass of N2 and the molar mass of 3H2. Now, lastly, I have to calculate the molar mass of NH3, okay? So, for 1 NH3, that would be the mass of 1 nitrogen plus the mass of 3 hydrogen, okay? So let's calculate that. So 1 NH3 is going to be 14.01 plus 1.01 times 3, right? Because there's 3 hydrogens. So 14.01 plus 1.01 times 3 is going to give us 17.04. But we have 2 of them, okay? So now 2 NH3s times the mass of 1 NH3, which is 17.04, gives us our total mass of 34.08 grams. Okay, so these are my calculations again, so that you can look at them. Okay, so now we can move back down and do our last interpretation, our interpretation in grams, using all the numbers we compiled up here. So we have 28.02 grams of N2 plus 6.06 grams of H2, which gives us 34.08 grams of NH3. Okay, that is our last interpretation. So this is what you would type into the answer box, okay? And there should be a chemical keyboard available for you so that you can type in all the subscripts and the arrows, all right? So this is what I'm looking for in your box. Now, go forth. This helps you answer questions 1, 2, 3, and 4 in the Junopod. And then the next video is going to go through how to answer questions 5, 6, and 7. Okay? Thanks, guys.